This is a CCEA Mathematics M4 January 2019 paper. Let's take a look then at question 1. It says then, a badge is the shape of a quarter of a circle as shown below. Calculate the perimeter of the badge. So we need to find this bit here. That's a tough bit, and then add 9 and 9. So I'm going to find the circumference as if it was the whole circle. So circumference is going to be C is 2 pi r. So that's 2 times pi times 9. And that gives us 56.548 or 549 possibly. We want to divide that by 4. So therefore a quarter of the circle is going to be 56.549 divided by 4, and that gives us 14.137. That's the quarter circle bit. We then need to add the 9 and the 9, so we'll go 14.14 plus 9, and that gives us then 32.14. On to question 2. The test scores for the 10 boys in a class are these. The mean test score for the 5 girls in the class is 8. Calculate the mean for this class. So we need to work out the total of the boys, so we just add those up. So our boys total, adding those up then is going to give us 65. The girls total we need as well. And so if the mean for the 5 girls was 8, that means the sum of all their scores must be then 5 times 8, which is going to be 40. So our total, if you want to call it that, is going to be 105. And we have 10 boys and 5 girls. So to find our mean, we're going to do 105 divided by 15, and that gives us 7. Question 3, given that 4,500 is 2 to the power of a times 3 squared times 5 to the power of b, work out the values of a and b. A couple of ways of doing this, but I'm just going to split up 4,500 into its prime factors. So we can either do it by our factor tree or just keep dividing then by the next prime. So you get divided by 2 again. I'm going to split it up. So 45 times by 100. It's one way of going. Then this would be 5, and then this would be 9. Note now I'm doing a square round it every time I see a prime. So that's a 3, and that's a 3. The 100 then, 10 and 10, neither of which are prime, so I'm doing a circle. 2 times 5, and then 2 times 5. So that means that 4,500 is actually equal to 2 times 2, so that's a 2 squared times 3 squared, which we had anyway, times 5. So many 5s, so have 1, 2, 3, so that's 5 then to the power of 3. That means my answer for A must be 2, and my answer for B must be 3. Hence, write down the lowest value by which 4,500 needs to be multiplied to make a cube number. So we need to make each of these powers then up to a multiple of 3. Here we have a 2, so we need to multiply it by 2, and we would need to multiply it by 3. The 5 is already a power of 3, so we're fine. So 2 times 3 then, and their answer is going to be 6. Speeds of cars on a road are recorded over a period of time. The results are recorded in a grouped frequency table. How many cars were travelling at more than 40 miles per hour? So that's 40 to 50, that's 50 to 60, that's 60 to 70, so it's 18 plus 2 plus 2, which is going to be 22. Which class interval contains the median speed? If we get our total here, let me see, that's going to be 30, 40, 50, I think that adds to. That's going to be 30, 46, that's 50. So we're looking for between 25 and 26. So that gets us to 12, and then that will get me to 28. I hope you follow that there. So it's 12 plus the 16 gives you 28. So the 25th and the 26th car is in this group here. So we would write down 30 to 40. Final question then, calculate an estimate for the mean speed of the car on the road. That's actually what the other two columns are for. So we need to find then first of all our midpoint. Midpoint of each of these groups is nice and straightforward. 25, 35, 45, 55, and then 65, and then we're going to find our fx column if you want. If you want to call this x, that's okay, and then fx or f times midpoint. And we have those, so we're going to do then 12 times 25, which is going to give us, I'm just getting my calculator here, although I'm sure I can work that one okay. So my 12 times 25 is going to be 300. This one here, 16 times 35 is 560. 18 times 45 is 810. 2 times 55 is 110. 2 times 65 then is 130. If we add all these up, we get 1910. Therefore our estimated mean equals 1910 divided by 50, and that gives us a value then of 38.2. Question 5 then, a child's height increased from 84 to 91. Calculate the percentage increase. So this has increased then by 7. So it's going to be 7 over 84 and then times by 100% to get our percentage, and so that's going to be then 8 1/3 or 8.33. Either of those would be fine to put in as your answer. Question 6, ABCD is a square of side 6 centimeters. How much longer is AC than AD? So AD is, we can see then, is 6, and we need to find in our AC. So we're going to use Pythagoras here. We'll label our sides A, B and C. C squared equals A squared plus B squared. C squared equals 36 plus 36. So obviously C then is going to be, add those two together to get 72. We want the square root of 72. So our side then is 8.485. How much longer is one than the other? So we can go to our two decimal places here then. 8.49 take away 6 is then going to be 2.49 centimeters. Question 7. Peter, Jack and Colin share a flat. They pay the rent monthly. Peter pays 30%. Jack pays 3/8. Colin pays 520. Calculate the monthly rent. So you can change it all really the same thing. So Peter is 30%. Jack, 1/8 is 12.5%. So 3/8 is 37.5%. That means Colin is paying how much? That's 67.5%. So he's actually paying then 32.5%. And we know 32.5% equals 520. I would then find 1%. So I divide both by 32.5. 1% then is 16. And we're pretty much there. Calculate the total monthly rent. So 100% is going to be then £1,600. Question 8, factorise each of the following. Quite a strange question this, because it says to do the same thing every time, but each question is slightly different. So 10 CP, so we're going to set it up like this. What number can I take out? I can take out a 2. There's a common C there, so I can take out the C. There's a common P. I can take it out, and then nice and slowly, what do I multiply this by to get this? 2 times what gives me the 10? That's going to be 5. C is there, and P to P squared is going to be P. Take away 2 times what gives me 4 is 2. So that's my answer then for that. So it's going to be 2CP upon 5P, take away 2. Next one is a quadratic, but it's a special type of quadratic known as the difference of two squares. So this one we could nearly put the answer just straight in. Is going to be y plus 1 upon y minus 1. Next one, again, is a quadratic. We're looking for two numbers and multiply to give minus 3. And the same number, two numbers add to give minus 2. Because it is a 1k squared term, we don't need to split our middle term, so we can then have k. So what are our two numbers and multiply to give minus 3? They're going to be minus 3 and then k plus 1. Checking then, if you add those, you do indeed get minus 2. Multiplying them, you get minus 3. So just fill our answer in here, k minus 3 upon k plus 1. Next one, again a bit of a strange one. So there's a common x minus 2 there, which we can take out. So it's x minus 2. I'm going to do a big strange square bracket here. Hopefully it's not too confusing. X minus 2 times what gives me this? It's x minus 2. And then x minus 2 times what gives me this? It's going to be a 5. You don't need the square bracket, it's just to kind of differentiate it then kind of from this bracket here so we don't get confused. Tidying that up then, inside is going to be x plus 3 because the minus 2 and the plus 3. So our final answer then is x plus 2 upon x, sorry, that's x minus 2 upon x plus 3. Okay, we have algebraic equation then to try and solve. A couple of ways of tackling these ones. We can make the denominator the same and then just get rid of it. That's what I'm going to do here. So I'm going to times top and bottom of this one here by 3. That's going to give me 3 upon x plus 3 all over 6 equals 5x over 6. Multiplying it out, we get 3x plus 9 over 6 equals 5x over 6. Now I'm going to multiply, set this up like our equation. I'm going to multiply both sides by 6, and that just gets rid of the fraction then. So we now have 3x plus 9 equals 5x. Take away 3x from both sides, and we get 9 equals 2x. That gives me then 4.5 equals x. So x then is 4.5. Now plenty of other ways of tackling this one. Some people might want to cross multiply. I don't like doing that. You can do it because there's a cross and equal sign, but just tread carefully with those ones. Hopefully that's okay. Question 10 then is a cumulative frequency one. So this cumulative frequency table gives data about the length of time it takes for 50 workers to travel to work one morning, and they have everything here. Now note here they've actually given us the cumulative frequency. That's not always the case. Sometimes they give the frequency and we need to add our extra column and work out the cumulative frequency, but in this case it's been given, so we can just plot it straight on. I've got the other page here in front so we can plot it straight on the graph. So at 20 we're going to plot a 7. So let's move so we can see here. So 20 is going to be 7. 25 is going to be 22. 30 is 36. 35 is 45. 45 is 49. And 60 is up then to 50. At this stage we want to do as best a curve as we can. This is easier said than done sometimes, but you do not join them together with your ruler. It's not a straight line here, and just join them up and try and make the neatest curve that you can. If I join then something like that, so that then should be my cumulative frequency curve. The next question says, use the graph to estimate the percentage of workers whose journey time was longer than 40 minutes. So we want to show the person that's marking this so we know what we're doing here. So here's our 40 minutes. So I would do a nice thick line going up here. You might even want to put an arrow to show the direction we're reading. So we're going up this way, and then I'm going to read across. So I'll go about there. I think that's not quite as accurate, but I'm sort of looking at what they're looking for. So that then is going to be 47 is where I'm reading that off. Okay, use the graph to estimate the percentage of workers whose journey time was longer than 40 minutes. So let's think about this. 47, but the 47 of the people were shorter than 40 minutes. So that means it's going to be 3 out of the 50. As a percentage then, that's then going to be 6%. Obviously 6 over 100 is what we're looking for there. Question 11 then, PQR is a right angled triangle, and we have this information here. How many degrees is angle P bigger than angle R? So we're going to need to use trigonometry then to find these two angles here. So I'm going to set it up for this one, and then we'll worry about the other one in just a second. So if this is my angle here, then this is going to be H, and this is going to be A. So I have A and H, and so I'm going to be using cos. My formula for cos, or my ratio for cos x equals A over H. Cos x is 5.4 over 13. X then is going to be cos to the minus 1, or shift cos. You all know how to do that in your calculator. And you get an angle then of 65.456, or in and around there. You could set this other one up here and do SOHCAHTOA again in trigonometry and work it up, but now we know this one, we can just take it away from 90. We know this is 90. These two must add up to 90. After all, it is a triangle. So if that's angle P, then our angle R is that taken away from 90, which is 24.54-ish. If we take those two away, then we get an answer of 41 degrees. Next one then is number 12. Find the equation of the line which goes through 0 minus 4 and is perpendicular to the line 2x plus 3y equals 9. I would want to rearrange this one to get it in the form y equals mx plus c, and then I can find the gradient from there. So let's go, if we go 3y equals minus 2x plus 9. Now if I divide by 3, y equals minus 2/3 x plus 3. The equation of this line, so the perpendicular of this line here, so here is the gradient of this line. If a line is perpendicular to this line, then the gradient of it must be the negative reciprocal. So I get rid of my negative and I turn this upside down. Therefore 3 over 2 is the gradient, which is m. My equation then is y equals mx plus c. So y equals 3 over 2x, and it says it goes through the point 0 minus 4. Draw this out if you wish, but here is your y-axis, here is your x-axis. That's actually giving you the y-intercept there as minus 4, so we can sub that straight in then for a c. So it's y equals 3 over 2x minus 4, which is our answer then. That's going to go down there. Alright. Next one then, simplify fully. This is quite an awkward looking one, I have to say. So we want to factorize this, and hopefully then there'll be common factors that are going to come out. So our top line we can factorize to give us what comes out there. There's a 3 and an x, and then there's hopefully going to be an x minus 2y and that's then going to be our top line. Bottom line is a wee bit tougher, so let's see if we can suss out what we'll have to do here. I might want to draw my wee line down here and then factorise. They've kind of already split our middle term for us. I don't know if that makes sense, but I can take out a 4x out the front here. So that's 4x upon x minus 2y. Secretly, that's good news. I'm happy to see an x minus 2y because I know it's going to cancel with the one up here. X minus 2y here. What do I multiply this by to get this? It's going to be minus 3y. Sorry about the writing there. That means I can rearrange this, and it gives me, what do I have? 4x minus 3y, and then x minus 2y. That cancels with that. So my final answer then is 3x all over 4x minus 3y. Question 14. A cliff is 130 metres high. From the top of the cliff, the angles of depression of both due east and level with each other are 14 degrees and 21 degrees respectively. Calculate the distance between the boats. The angle of depression is this angle here. It's the angle, if you're standing on top of the cliff, say you're here and looking straight out, it's the angle that you need to look down. Alright, so this one here must be, it's a bigger angle, isn't it? It is, so this one's going to be then the 21. I'm going to take this triangle here, and hopefully we can see that this distance here is the same as this distance here, and this then is going to be 130. So I'm going to try and work out this distance here. We're going to be using tan for that. How do I know that? So that's going to be O, and that's going to be A. So we're going to work out our A and go then from there. So we're going to go for tan x equals O over A. Tan x equals, let me see, 130 over A, and sorry, I should change that then to a 21 obviously, so tan 21 is that. Rearranging that, we'll just do that in one step. A is 130 over tan 21, so A in this case is going to be 338.662. We need to do the same thing. Sorry you couldn't see that. 338.662. We need to do the same thing for then this boat. I would be tempted to draw the thing out again, just so we can see exactly what triangle we're dealing with. So this distance is going to be a bit longer. I mean, the other way is that you can obviously take this triangle here, and annoyingly in this case it actually makes the working out the trig function slightly easier, but that's okay. This one's going to be 14 degrees. That's 130, and again we're trying to find this distance here. So we're going to go tan x is O over A. Tan 14 is 130 over A. Just give me a wee second. Okay, so where were we? We're going to our A then for this one is going to be 130 over tan 14. In this case our A comes out, I think, to be 521.402. That is that distance there. No, it's not. It's that distance there, and we've worked out that this distance here is 338. So we subtract those two distances, and we would get 183. Question 15 then is a max and min problem. A train travels 736 kilometers correct to the nearest kilometer. A journey takes 4.5 hours correct to the nearest 0.1 hour. Work out the minimum possible average speed and the maximum possible average speed. So our speed obviously then is going to be distance over time. And for our minimum, we are going to want the smallest value here and the biggest possible value here. So the smallest value that this could be is 735.5, and then this is to the nearest 0.1, so the highest it can be is 4.55. So if we divide those two, we get 161.4 0.64, no, 65 I think. So that is our minimum. And for our maximum, we want to make the top one as big as possible, so that's 736.5, and then make this one as small as possible, so it's 4.45, and that gives us then 165.506. So 165.51. Question 16. The weights in grams of a collection of waste bags from a hospital are shown. We have our frequencies here, we have our groups, and we have to draw a histogram. So I've kind of got a wee bit ahead here and added the extra 2 columns in. We need a width column here. So the width of this group is 20, 10, 15, 10, 55 to 95 is 40, 95 to 115 is 20, and then that one's going to be 25. And so to find then our frequency densities, which is my FD here, I do 5 divided by 20. That gives me 0.25. I then do 8 divided by 10, which is 0.8. 24 divided by 15 gives me 1.6. 38 divided by 10 gives me 3.8. 64 divided by 40, 1.6. 1.8 here, and 1.8 then as well. Draw a histogram on the axis provided to illustrate this data. So the first one between 0 and 20 is 0.25 high. I've taken a look at the scale. It goes here from 0 up to 140, so that fits nicely in here as we would expect. And then the frequency densities have to go up as high as 3.8, so again I've gone 1, 2, 3, 4, and it fits in nicely. So hopefully it'll be okay. The first one between 0 and 20 then is 0.25. So I'll draw my line then across here. The second one is between 20 and 30, and it's 0.8. So I'll draw this line here. The next one is 30 to 45, and that is going to be 1.6. The next one is from 45 to 55, and that is going to be 3.8. So it's 3.8. Join in some of the other ones here as well. Now I have them done. The next one is 30 to 45, that's okay. 55 up to 95, so there's 80, there's 90, so 95 is going to be here, and it's 1.6. And the next one then is going to be 1.8. And it's 1.8 right to the end, so we can take that up to 140 and then draw our line in after that. And my last two lines is to 115, which I think then is going to be here, and then a line then just to finish this off. They would expect to see the scales drawn in. They would expect a label here, and then obviously a label here, so this is weight. That's what we have then from there. On to the next part. These bits tend to be quite tough. Estimate the number of bags which weighed more than 60. So ones that weighed more than 60, I'm always tempted for this to just look at the table. I think it makes a bit more sense. So these ones are definitely more than 60. That's fine. Those are more than 60. That's fine. This group here is a size 40, and 60 appears an eighth of the way through. So we want to take then 7/8 of this. So it's 35. 7/8 of 64 is nice and straightforward. That's going to be 56. So we want to take then 56 from this group and then add on then to there. So how would I show that? It's going to be 7/8 multiplied by 64 plus 36 plus 45. That is 56 plus 36 plus 45, and that gives us then 137. A stratified sample of 70 bags are selected from those with weights less than or equal to 95. So that's going to be this group here. If you can see that, I've just put a square around. There's the one. So we're taking 70 from this. They add up, by the way, this plus this plus this plus this plus this. Let's see what we're working out here. We have to do then 5 plus 8 plus 24 plus 38 plus 64. They're all the ones that are less than 95, and it comes into 139. And we need to then look. A stratified sample of 70 bags are chosen from those with weights less than or equal to 95. Estimate how many of this sample weighed less than 40 grams. So which ones then are going to weigh less than 40 grams? So it's going to be this one, and it's going to be this one, and then a bit of this group. Can we see then if this group size is 15, then anything from 30 to 40 is going to be 2/3 of this. That's quite an easy sum. 2/3 of that then is going to be 16. So the way we would write that is then going to be the 5 plus the 8 plus 2/3 of 24. So it's 5 plus 8 plus 16. And that then gives us 29. So there's our fraction, 29 over 139. And then we times by 70 because our sample size is 70. So it's 29 over 139 times by 70, and we get then 14.6. They are happy enough then to accept an answer of either 14 or 15 in this case, and so that would be that bit. Part D then says the weights of a second collection of bags shows the histogram below, and we have to find an estimate for the mean weight for this collection. So what are we going to do? We need to write out our groups. You nearly work backwards towards our table. That one's going to be 0 to 10, then 10 to 15, 15 to 20. But effectively we're going to end up taking the midpoints of each of those whenever we're working out our estimate for the mean. So down here I've written then my weights of what they're going to be. So taking the midpoint then for each of these values, 0 to 10 is of course going to be 5. 10 to 15 is 12.5. 15 to 20 is 17.5. 20 to 35 is 27.5. 35 to 45, finally a nice one, which is 40. 45 to 55, which is 50. 55 to 60 is 57.5. If we have a histogram, how do we work out our frequency? So that's our next question. Here the frequency density you can see then is 2.6 and the group width is 10. So we need to multiply this up. So 2.6 times 10 is going to give us 26. 3.2 times 5 gives us 16. 3 times 5 gives us 15. 1.4 times by 15 gives us 21. 3.7 times by 10 gives us 37. Where are we? 2.4 times by 10 gives us 24. And then finally 1.2 times by 5 gives us 6. Alright, here are our frequencies. Here are our midpoints. So we're going to then do our midpoint times frequency. Again, you could call that x if you wish and go for fx. And those are 5. 5 times 26 is 130. 12.5 times 16 is 200. 17.5 times 15 is 262.5. 27.5. 27.5 times 21 is 577.5. Multiplying this, 1480, 1200, and 345. So our estimated mean, then, we're almost there. The total of this, if you add these up, you get 4195. If you add these up, you get 145. So 4195 divided by 145 gives me 28.93. Final part of our histogram question then is estimate the median weight for this collection. Another reasonably tough one, so we need to go back really to our table and see what we're going to go through. It's 145. If I divide 145 by 2, I'm looking for the 73rd one. So the 73rd one, this takes us to 26. Let's take a look at our frequencies. This takes us to 42. This takes us to 57. And this takes us into 78. So it's in this group here, which is the 20 to 35 group. And can we see then we're looking for, if that's 57 and we want to get up to 73, it's going to be the 16th out of the 21 that we're looking for. So we're looking for 16 over 21 of the way through the 20 to 35. So it's reasonably tough to work out. So let's see what sum then we're going to have to do. So as we say, it's the 73rd one that we're looking for, and it's in the group from 20 to 35. So we are going to be doing, the median is going to be 20, because that's the start of this group here, plus 16 over 21 of the way through the 15, which is the size of this group here, and that gets me then 31.4. So my answer is 31.4. A tough question, just to show you that again. We're looking for the 73rd, of course, because it's 145, so 73 is right in the middle. We go through up to here. That gives me the 57, that gives me the 78. So 57 up to 73 is 16. So we're looking for 16 21sts, I guess, of the way through the 20 to 35 group. So we need to find 16 over 21 times by the 15, which is the size of that group, and add it on then to the 20, which is what we've done then to get our 31.4. Okay, so in the diagram below, 0 is the centre of the circle, P, Q and R are points on the circumference, and R, S, T is a tangent to the circle. So it says, first of all, you can't see it down below, it says calculate the angle ROT. So ROT, can we see it's actually this rule here? This goes to the centre and this goes to the other side. So this is going to be twice 36. So that's a nice straightforward one for us then. It's going to be 72. The next one is OTR. So this is 72. We may as well put it in here. OTR is this. This is a tangent. This is a radius, so that must be a right angle. That means these three angles add to 180, or these two add to 90, and so that means that's going to be 18. Angle QSR. So what do we have here? This is this point here coming up from there. That then must be 36, because those are coming from the same point. If that's 36 and that's 90, then that one must be taken away from 90 is 54. So that's the angle we require. Part B then, O is the centre of a circle through A, B, C. And DCE is the tangent, and angle AOC is 118 degrees. The bit below then says find the size of the angle ACD, give a reason for each step. So A B C is going to be half of this angle here, because, so let's go for A B C is equal to half of 118, and our reason is because angle at centre is twice angle at circumference. So we know then that that is going to be 59. If that's 59, that there has to be 59, and that's our alternate segment theorem. So I would write then, sorry, my reasons actually should have been down here, but that's okay. And so then angle ACD then is going to be 59, and we know that ABC equals ACD by the alternative segment theorem. There is another way of doing it. You can split this up and work out different angles and eventually get there, because that's going to have to be 90 degrees. That would be another straightforward enough way of doing it if you wanted. That's 118. Those are both radii, so those two angles are the same. Take this one out from 90, and that's going to give you 59 as well. Another method which would be totally fine. Again, you need to explain what you're doing. Part 2 then, angle BCE equals x. So here's our BCE here. We're told then that that is going to be x, and it then says express angles BAC, so that's this angle here, and BCA, so that's the other angle in the triangle, in terms of x. We could have then that that's 59 as well, or that would be okay. So let me see, angle BAC is just simply going to be x, because again of our alternate segment theorem. So that's just going to be x. Angle BCA, we can do it a couple of different ways. It doesn't really matter. But if we know that that's x and that's 59, then that then has to add to 180. Or we could do it just kind of with a straight line down here. Again, they're just sort of both the same. So this angle here, so BCA is going to equal to 180. Take away x, take away 59. If I tidy that up, 180 take away 59 then gives me 121. So it's 121 take away x. Question 18. The diagram represents the frustum of a solid cone formed when a small cone is removed from the top of a large cone. Work out the total surface area of the frustum. So we're going to need the curved bit. We'll chat about that in a second. The circle on the top and the circle on the bottom. So how are we going to work out the curved bit? We can work out the curved surface area of a cone. So we're going to do the whole cone, the whole big thing, and then take away the small cone, and that's going to give us our curved surface area then of the frustum. So let's write that down. Our curved surface area of frustum. Again, if you look, remember you have the formula for this, so it's actually pi RL, and L then is your kind of slant height. So in this case, it's going to be pi times 9 times 15. That's the whole cone. Sorry, you can't see that. Take away the wee cone, which is pi times 3 times 5. If you put that into your calculator, you will get something around 376.99. So that's our curved surface area. We've got that. We now just need to add the disk at the top, the circle at the top, and the circle at the bottom. So top and bottom circles. So it's pi r squared, obviously, so it's pi multiplied by 3 squared plus pi multiplied by 9 squared. And if you put that again in your calculator, you get 282.74. If we add these two together, so what have we worked out again? This is this curved bit right here. This is the top and bottom circle. So we add these two together and we get our answer then, which is going to be 659.73. Okay, question 19. A is a fraction whose denominator is 3 more than its numerator. So we could write A then as x over x plus 3. A new fraction B is produced. 4 is added to the numerator of A to give the numerator of B, so that's going to be x plus 4. And then 4 is added to the denominator of A to give the denominator of B, so let's add 4 to this, and I'm going to get x plus 7. Fraction A is now bigger than fraction B is now bigger than fraction A by an eighth. By setting up and solving a suitable equation, find the original fraction A. Okay, so this one, take away this one, must give us an eighth. So let's write that. X plus 4 over x plus 7. Take away x over x plus 3 equals an eighth. And we need then to try and solve that. We're going to find the common denominator. I need to multiply top and bottom of this one by this. Top and bottom of this one by this. So it's going to be x plus 4 upon x plus 3 all over x plus 7. X plus 3. Take away x upon x plus 7. X plus 7, x plus 3, and that equals an eighth. Joining together our top lines then, we can go x plus 7, x plus 3, all over x plus 4, x plus 3. I'm then going to go minus x upon x plus 7 equals an eighth. I might run out of space here, but it should be okay. Multiplying this out and multiplying then through by your bottom line. So here we're going to have, I'm going to do FOIL x times x is x squared. Outer and inner give me 7x plus 7x plus 12 minus x squared minus 7x. That equals then an eighth. And then if I multiply out this, I get x squared plus 10x plus 21. Here the x squareds are going to cancel, which is quite nice. Here the 7x's actually cancel each other out, which is nice, and I just end up then with a 12. How do I get rid of the fraction? If I multiply both sides of this by 8, I'm left with this on the right hand side, and I'm left then with 96. So 96 equals x squared plus 10x plus 21. Rearranging gives me x squared plus 10x minus 75 equals 0. That's how we solve a quadratic equation. We get everything to one side and then 0 to the other. I'm looking for two numbers that multiply to give minus 75. The same two numbers add together to give 10. So that's going to be then x plus 15 and x minus 5 equals 0. So either then x is minus 15 or x is 5. We're obviously going to take the positive value here, and if x is 5 and we sub it back into this, we're going to get 5 over 8. You could take the negative one if you want. I think you end up then with what, like minus 15 over minus 12, but 5 over 8 is what we're looking for. That's us finished. I hope you got a few questions right.